2, 1. Okay, so welcome back. I guess it's the continuation for the grade 11's course on functions. Now here, factoring, and when you run into factoring, you obviously have done it in grades 10 for sure, possibly in grade 9, depending on your teachers. So it should be more or less a review for you, but of course we forget. So it's good to kind of brush up on these items. So now I've done quite a few videos on factoring, so I'll point you out to those in just a second. But I do want to go over just a few examples to kind of bring you back and let's see what you remember, and then you can gauge on which videos you want to watch for other reviews. So the first thing in terms of factoring is for sure the greatest common factor. And when you're just dealing with numbers, trying to find the greatest common factor is much simpler because you don't really have any variables. But once you run into, kind of polynomials, then finding the greatest common factor is a little bit tougher. It's more challenging, but it is for sure the simplest way to be able to factor a polynomial in an expression. So here are two expressions for greatest common factor, and I'm going to do this just by example. And greatest common factor means that if you have certain amount of terms, what you are looking for is you're trying to find basically the factor, which is the biggest factor possible that you can take out from every single term. So in our first example, we have 3 of these terms. And so here are my 3. So here's my first term, my second term, and then here's my last term. And now what I'm looking for is I look at the coefficients and I basically treat them like if I would have just regular numbers, so natural or numbers or sometimes integers. And then what I want to be able to do is I want to be able to take out, the greatest common factor from those coefficients. So I have 3, 9, and 12. So I guess it's negative 12 if you want to take in the signs. Now, the number that goes in or that I can factor out of all of those is definitely 3. I mean, 3 is the biggest one that I can take out of my first coefficient, and it certainly is one that I can take out from the rest. So for instance, that's how I begin. I just simply look at my coefficients, and I'm going to take out, the biggest one out of 3, 9, and the 12 is the 3. Then I start looking at the actual variables. Now in this case, I only have x, and I do have x in all the variables. And now the other component of x that I am looking for is, so how many of these x's do I have in each? Well, I have a 4, 2, and then the last one I only have 1 x. And as you know, you're typically kind of bound by the smallest number of exponents. So in this case, it's the last term, which has only an x. I can't really take out more than that because my last term only has an x. So I'm going to take out, so here from these, I'm only going to take out an x altogether. And now the question is, so if that is my greatest common factor, what is remaining? Well, what's going to be remaining is in my first term, all I'm going to have left is x cubed. In my second term, all I'm going to have left, now I have a 3 left, and then I have an x left. And then in my last one, all I'm going to have left is the 4. And now this becomes your greatest common factor, and you've basically factored this out. Now we can try and see, can we maneuver anything out of this within here to try to factor this out in any other way? But that's for another step. For this moment, you should be comfortable in kind of remembering the greatest common factor to take out of an expression. Now, in my second example that I have there, so with that example, again, I have 3 terms. You don't always have 3 terms. You can have as many terms as there might be. And now I have coefficients, right? I have my first coefficient is just really 1. Then I have a 3 or a negative 3 if you take the sign, and then I have a 1. Well, if I have 1, 3, and 1, then I can't really take out anything because I am bound by 1. So I'm not going to be taking out any coefficients at all in terms of factors. So then I move over and then I check my variables. So now in this case, I have 2 variables, x and y, and it actually turns out that I have x and y in all the terms. So I'm going to start with, for instance, x. And in this case, so what do I look for is, all right, so I have two x's in the first term, 1, and then I have 3 at the end. So I am basically bound by the smallest one there, so I can take out an x from here. Then I move over to the y's. Now, how many y's do I have? Well, I have only 1 here, I have 1 here, and I have 2 over here. So I can take out 1 y. And that becomes my greatest common factor from here, because the rest has to remain. And in this case, I'm going to have an x remaining only from the first term, because the y I took out. The second term, so the 3 remains there. I'm taking out the y and the x, okay, so there's nothing else remaining from there, plus. And then finally, my last term, what I have is I have 2 x's remaining, and then I have 1 y remaining. And that is all that I would have for that. And this becomes now my greatest common factor right there. And this was for the first one. So that should be a review for you, right, in some sense. Now, if you want to see some more examples, I'll put up a link up above. It's kind of grade 10 content that you can take a look at. The next set of factoring that you have run into is basically quadratic factoring. You know, you have run into numerous quadratics, and there are multiple things in terms of quadratics that we can use. You know, if we're lucky enough, we'll have perfect squares, which we can factor out quite nicely. And if we, again, are lucky enough, maybe we have a difference of squares, which again, we can factor out relatively nicely. It's just a matter of you being able to see that it's a difference of squares. And then if those two don't work, you know, sometimes we would use decomposition. So we would use all of these. Now for perfect squares, again, if you want a lot more, I'll put up a link, okay, to the grade 10 content on that. But in terms of a review, well, to notice a perfect square is, so the way that I kind of look at, is I always kind of look at only just the first and then the last terms here. And then I check, okay, so I take the square root of both. Now, if I take the square root of both, I'm going to get, so this is going to be 3x, okay, is the first one. And then the square root of the 25 is just 5. I look at the sign right there to see, and that sign is negative. So this sign we put in here, and that's the square root of that 25. And now the idea is, okay, if this really is a perfect square, then, okay, if I would expand this out, then I should get this middle term, which is minus 30x. So indeed, that's exactly what would happen here. So perfect squares are kind of nice. You know, again, you can take the square roots, you look at the sign, so the sign right there, you put the sign in here, and then you can just kind of expand. Maybe if you're good, or maybe if you practice quite a bit, you know, you can maybe do it in your head. If you're like me, I kind of pre-did this, so I know that it was a perfect square, but I typically just write it out. I'm not really that good in terms of kind of memory work all the time, especially if it's like tests or something. Then I would just simply expand it and then check if it was a perfect square. So that's one way to factor. So notice this polynomial, in this case, so this expression that I had, so this entire thing, so if I would start from the beginning, let me just kind of remove everything we put in here. So if I take this expression, you know, I can certainly factor it out, and this looks much nicer and cleaner. So those are perfect squares. And again, if you want more, you can go back to that link that I was pointing you out to. Now, what about the difference of squares in terms of trying to review that? Now, difference of squares kind of always have this form where, you know, we would notice that we have, so kind of like this. So it's x plus y multiplied by x minus y. So it is, you know, we have something inside, whatever x and y might be. Now, they don't have to be just x's and y's. They can be anything else. But the point is that these always turn out to be, and give us this nice breakdown of two terms, okay, and then separated by a difference. So here is the difference, the subtraction that we have. And if you notice that, it kind of works exactly the same way as your perfect squares, where you're basically taking the square root of your first And in this case, if I take the square root of that, it's going to give me y squared. And then you take the square root of the second and you check, okay, is it a perfect square or not? 121 is actually 11. So I have now 11. Now, because there is no middle term in this case, and the middle term disappears because you had difference of squares. So if you expanded this out, you know, so those middle terms, which would have been xy minus xy, they just subtract from each other. And then all that is left is basically your x squared right there. And then what you have is your y squared there at the end. Okay, so those are the ones that you have. And from there, you know, here's your difference of squares. So to factor this out, okay, this would be basically now, so 1 is going to be positive, and then you need another factor, which is now going to be negative. And if you expand this whole thing out, you're going to return right back to here. Now you might say, okay, well, this looks nice and I factored it. But you know, the original one looked nicer and it's only had 2 terms. Now I have these 2 factors that I have to multiply and think about. So that's true. I mean, a difference of squares kind of looks neat because it only has 2 terms. And however, if you're asked to factor it out in school, or at some point you might run into it because maybe you're trying to find roots or something like that, then you know, it's good to know how to factor in terms of difference of squares. If you want to see more examples, I'll put up a link there to the grade 10 content on difference of squares, which I think is pretty useful to just run yourself through a few examples so that you can try them. The last one for the quadratic factoring typically might be something to do with decomposition, because you're not always as lucky to get perfect squares or difference of squares. I mean, those ones are great. And, you know, so this one, so 6x squared minus x minus 2, you right away notice, I mean, 6x squared, if you take the square root, doesn't really work, you know, and then if you take the square root of 2, well, you're going to get square root of 2. So it's not really a nice perfect square that we have to work with. So what can we do? I mean, sure, I guess you can guess things. You know, another one you can possibly, you know, think about kind of the quadratic formula to think of roots in general to try to help you along. Or, you know, you can do the decomposition. So decomposition is, you know, takes time because you are going to be doing a little bit of guessing, but at least it's guessing with some kind of method behind it. All right. So I'll put up a link to decomposition up above, again, to the grade 10 content, because it was covered there if you want a lot more. But here in terms of the review, okay, so just so that you kind of get back into it, decomposition basically works if perfect squares and difference of squares doesn't snap at you when you're looking at the question. Then what you try to do is you take your middle term and you try to break it down in basically 2 things. So that we want to decompose that negative x into 2 terms. We want to be able to add or subtract 2 terms in such a way that those 2 terms, okay, when they're added or kind of subtracted, they're going to give us, as a result, negative x back. So meaning negative 1, because there's a negative 1 in here. All right, so what are 2 numbers that you're going to add or subtract that can give you basically negative 1 back in return? And then what you do in decomposition, the other component is that you're going to take your numbers, okay, so plus your signs here, and when you multiply, right, so if I multiply these out, then I'm going to get negative 12. So let me remove this and put negative 1 in terms of the addition or subtraction, and then multiplication is going to have to give us negative 12 back out of it. Okay, so if that's the case, so I have to now think, and this is where the guessing comes in. So what are 2 numbers that if I add or subtract, they're going to give me negative 1, and when I multiply are going to give me negative 12. So we know that one of them has to be negative because we have a negative 12 there. So what are 2 numbers? So I mean, I can kind of think the one that pops into my head is 4 and 3, right? So that definitely is going to give me 12. Now, which one is negative? Well, that is decided upon because here I have negative 1. So negative 4 plus 3 is going to give me negative 1. So that's the decomposition of the negative 1 that I have. So what I'm going to do is I'm going to have 6x squared minus 4x plus 3x minus 2. So that's what I have now. I have decomposed. Okay, so here is my decomposition of the negative 1. All right, so that's your original negative 1x. And now I factor this out. So I'm going to take these two, and I'm going to take these two. Okay, so I'm going to try to find for the greatest common factor in between them, or factors in between them. All right, so 6, 4, so I'm going to take out, I guess I can take out 2 and the x from here, which is going to leave me 3, I guess, x and minus 2 plus. So that tells me that now this has to be repeated within here because I want it to be a factor of both terms. So what can I take out? Well, I can't really take out anything except 1 out of that second, 3x minus 2. Now I have these, so these right here. So these are my now factors. These are supposed to be identical, so that's kind of what you're going to be looking for. And if I take that out, so 3x minus 2, so I'll take it from these two terms. So what's left behind is this. And now you have decomposed and you factored out your quadratic. So that's just kind of a deja vu in terms of review. Within grade 11, it's a concept that you should kind of remember from grade 10. So it's useful to know those quadratics. And again, you can go back to the link that I pointed out on decomposition if you want to see a lot more examples. Now, the last one, which probably wasn't as used in grade 10, is when you're trying to factor, you sometimes use grouping. And these ones, I mean, honestly, it is a little bit of guessing, right? You have to be able to practice and see these examples to be able to see, okay, so what can I group so that I can factor out later? So it's kind of like a puzzle because there isn't really a systematic way because it will depend on the polynomial that someone gives you. So here I have 3 examples and I just want to show you what we mean by grouping because they're not standard, right? I don't have a quadratic here in any of the cases. I have sometimes in the last one, I have 2 variables. So, you know, how do I factor this out? You know, so what do I do? And again, as I said, it is a little bit of puzzle solving within here. So let me kind of show you. I'll move this down a bit, okay, so I can concentrate on the first one. So this is what I mean by kind of grouping, and this is what teachers typically will mean by grouping, or if you are running it in a textbook. So within here, I can't really use the greatest common factor approach, right? Because I don't really have a greatest common factor to all of them, to all the different terms. So that's kind of the first thing that I always look for because it's the easiest one. So if that doesn't work, then I'm like, bummer. You know, so I like, what do I do now? You know, it's not a quadratic, so I can't use those rules. So then I know that I'm kind of stuck, you know. If in school they tell you to factor it, then you know that it probably factors in some way. In real life, if you know you ran into a polynomial and you try to factor that out, you probably are going to be guessing, and maybe it does and maybe it doesn't. All right. So, but we're going to play and see what happens. So what I notice if within here, and again, this is kind of more experience than anything, is that I do notice that I do have a quadratic right here. Now, and I am familiar with quadratics, I guess enough, that I know that I can factor them out. And I do notice that x squared plus 4x plus 4. So notice I can kind of play the game of perfect squares here. So this is actually a perfect square. Okay, so notice that that's the perfect square that I have in here. So that's out of that. So I grouped those 3 terms together. so that I can factor it out to a nice x plus 2 squared. Now that of course still leaves me with this, but within here, now I notice that, oh, okay, and again, this is just experience, kind of just looking through it, is, well, wait a minute, I have a negative here, this is squared, and this is to the 4th. So if I take the square root of this, so what I will get is, I'm going to have x plus 2, okay, so that's the first one, the square root of that. And then I have the square root of x to the 4, which is really nothing else but x squared. And because I have the negative, well, that's just difference of squares, right? So now if this is difference of squares, so that means, oh, great. So I can change this back into a difference of squares. This will be x plus 2 minus x squared. And that's how we could factor this entire expression. So that was by grouping and then noticing perfect squares and difference of squares. So, you know, understanding those quadratics does play a role. And then when you're doing kind of pedagogical, really just kind of school questions, you know, these things can nicely come out at you. So that's an example of grouping, where we grouped a certain amount, we simplified it, and then we could see that we can still simplify it even further, or at least we could factor it. So that would have been your answer right there. What about the second one? Can we group anything there? Well, so for the second one, what we have is x cubed plus 2x squared plus x plus 2. So, all right, well, this one, okay, it's cubed. So it's certainly, again, a quadratic won't work. Now, you know, do I have a perfect square somewhere in there? I don't know if that's going to help, okay, because if I take the quadratic, the 2x squared plus x plus 2, that doesn't really pop out at me in terms of a perfect square. So I'm kind of stuck. So, you know, what can I do in terms of grouping? You know, so let's try to find some greatest common factor in terms of grouping. So here is what I would have approached. Okay, so if that doesn't work, and again, I'm just kind of going through so that just to show you that it is a bit of guessing, right? And you might get frustrated, but it's kind of the nice ways of working with math and puzzles. So I'm going to, okay, so I'll group these two things together to see, okay? So if I group these two things together, I do have a greatest common factor between them, and that's x squared. And that's going to leave me just x plus 2. And notice, this right here is now x plus 2 right here as well. So what I can do is I can say, oh, okay, I can kind of do the same thing what I did in decomposition, where I have taken out my x squared from here, and that leaves me with just x plus 2, which is now going to be common to both. So it's almost like taking out a 1 here. And now you have a factor and a factor, which is the same thing. And we know that we can take out that x plus 2, and that's going to leave us x squared plus just a 1. And now we have actually factored this particular cubic. Okay, so that's pretty neat. Now this looks very close to difference of squares, but it is a plus. If it was a minus, then we could actually even break it down further, but it is a plus, so we can't really do anything else. All right, so that's kind of the grouping that you would see in this example. And it is a touch of guessing, to be honest, you know. So when I was preparing this, I did have to kind of think to try to set up questions to give you, you know, in terms of this grouping. If someone throws a question at me, like you are watching this video, then, you know, I wouldn't probably be able to do this as fast. I would have to kind of think and see, okay, you know, how can I group these things together if none of the other greatest common factoring or perfect squares, difference of squares, or quadratics in general will work. Here's the last one, and we're going to try to use now the same trick as we did just for the previous example. Clearly this is not a quadratic, right? We have multiple variables here. So what I'm going to do is I do notice that some variables have x's, some terms have x's, and some terms have my y's. You know how? So I'm going to try to group these things together. Let me group. So I'm going to try, because what I like to do is I like to group terms that have a lot of x's. So these ones have the most x's, and these ones have the most y's. So let's group those together. So meaning I'm going to just rearrange this. It's going to be like that. Those are the first two. And then I'm going to group the other. So kind of like this. All right, so here's my first group that I have. Here's my second group that I have. And now I'm going to try to do kind of like in decomposition. So I'm going to take out a greatest common factor from here. So that's going to be x squared, which is going to leave me x minus y. And then in here, I'm going to take out y squared. And again, it's going to leave me x minus y. So there we go. So we have a common factor now that we can take out from both. So x minus y, and this is going to be x squared plus y squared. And that would have been factored. Now, can I factor this any further because of the x squared, y squared? Again, it's not a difference of squares. So actually, I cannot. So that's kind of as far as I can push it. So here is the grouping of them. And then I just kind of took out greatest common factors. And then I had something in common. So that's the review that I have for you in terms of factoring and giving you some examples. You obviously will have to try. So try these on your own. You know, just kind of pause the videos, which is the best thing to do before you see the solutions. And then you just kind of work them out on your own. And then for all the quadratics and greatest common factors, you can certainly watch the videos that I pointed you to. All right, so thanks for watching. We'll see you in a future video. Okay, bye everybody.